So let's look now at the second part of exponential and logarithmic equations. And we still really just want to try and solve these types of equations. Now remember, from the very start of the chapter, we looked at exponential equations that had a common base. And if they had a common base, we could easily solve it, set the exponents equal to each other, and solve. With logarithms, we now have the power to solve exponential equations that don't have a common base. So something looks like this, that there's a 5 to the x plus 2 and a 3 on the other side, two bases that are different. This one also has a number that we can multiply by, but this allows us to solve these types of questions. And when you see a question that doesn't have a common base, you know right away it is a logarithm question. So how do we solve these? Well, it's really straightforward, step by step to solve these. First, we have to recognize there's variable exponents and no common base. If that's the case, then we try and log both sides. And we log it to, most times, base 10. Theoretically, we go to any base, but base 10 is usually what we do, log both sides to start. Then we use our log laws to move the exponents in front of each logarithm. Get those exponents out of the bases. At that point, we can expand things out, expand out the logarithms, and bring all the logs to one side. Then we can isolate for the unknown, use all our rules for mathematics. Usually this involves some factoring, and we want to simplify down to a single log. Once we have a single log, then we can find the numerical value, if it is possible, and at that point we would have our unknown. So we can use these 5 steps. The key here is to recognize that we have a variable in the exponent and there's no common base. So let's do this question. Solve for x in 5 to the x plus 2, which is equal to 2 times 3 to the 2x minus 1. And what we want to do is simplify first. We're going to follow our step-by-step process. Simplify if possible, which is already done. Well, we're going to log both sides. And logging both sides is literally just taking one side and writing a log and doing the same to the other side. Keep in mind that the original equation, whatever side you're on, that becomes the argument of the logarithm. Like so, we've logged both sides. That takes care of step 1. Now we're going to use our log laws to move the exponents down in front. So the first exponent, and this is where we have to be careful, the exponent is x plus 2, and that will come down in front of log 5. For the other side of the equation, though, we can't bring this exponents down yet until we expand out that argument. Log 2 plus log 3 to the 2x minus 1. That now allows us to bring down the exponent, so we'll have log 2 plus 2x minus 1 times log 3. And on the other side, we have x plus 2. And again, I'm just going to put it in brackets so we're clear, multiplied by log 5. That allows us to use the log laws and move the exponents down in front. Now we're going to expand out our logarithms. Expand them out so we have a series of logs that we can then solve for. Well, expanding is really just distributing. We're just going to multiply this logarithm into each of these values. That'll leave us with x log 5 plus 2 log 5 is equal to, well, we can't do anything with the log 2, so we'll just leave it the same. And this side, same thing. We're going to distribute this in 2x log 3 minus log 3. And it is going to get a little bit messy, but there's our expansion in. That takes care of the expanding piece. And then, this is important, we want to bring the logs that contain the unknowns to one side. So we're going to take our equation at this point and bring everything with an x to the same side and force everything else to the other. I'm just going to take this and move it to the other side. Of course, that'll force the non-variable log to the other side, and in the end we get x log 5 minus 2x log 3 is equal to log 2 minus log 3 minus 2 log 5. All the logarithms with variables are on one side, and all the logarithms without are on the other. Well, now we're trying to solve for x. We're trying to isolate and solve for the unknown. And you can see here, we usually solve this by factoring. We often now just factor out the unknown variable. That's exactly what we're going to do in this situation. We have a common x that can be factored out. Take out an x, and we'll be left with log 5 minus 2 log 3. And that's going to equal log 2 minus log 3 minus 2 log 5. Now we're almost there. Now that we have x all by itself, now we can divide both sides by whatever we don't want. And in this case, it's log 5 minus 2 log 3. And remember, for an equation, as long as we do the same to both sides, it doesn't change the equation. Log 5 minus 2 log 3. And that'll get us a value for x. These will cancel out, and we'll get an x value. And so x would equal log 2 minus log 3 minus 2 log 5 over log 5 minus 2 log 3. But at this point, we actually want to clean this up a little bit. We want to take this and write it a little bit simpler. And one of the ways we can write it simpler is first look at these two logarithms. Log 2 minus log 3, we can really write that as log of 2/3 minus, if we take the 2 and make it the exponent on the argument 5, we'll get log 25. Denominator here, log 5 minus, same thing, put that exponent up, log 9. Now again, it's simpler, but not quite simplified enough. We can go one step further. We can write these now logarithms as quotients. Log of 2/3 divided by 25, there's the argument, over log of 5 over 9, and we'll just go one step further to clean that up, and we get log of 2 over 75 divided by log 5 over 9. And there is our simplified logarithm. Now we could, at this point, take this value and put it in our calculator, it's all in base 10, and get an actual decimal, which in the end would give us a value of 6.1, and if we round to 2 decimal places, 7. There's our solution. There's our value for x to a decimal place, and you might do 1 decimal, 2 decimal, or you may just leave it as a simplified logarithm. Depends on the question, depends on what we're trying to find, but there's our solution. And it's just a matter of following the step-by-step process to solve when you have variable exponents and different bases. And we're going to do a number of examples like this in class.